Hello students. Welcome to Kirti classes. I hope you all are doing well. Today, we are going to study class 10 mathematics. Chapter 1, Real Numbers, exercise 1.2. In this exercise, we will prove whether different numbers are rational or irrational using simple logical methods. So, keep your notebook ready and let's begin our class. Our first question says, prove that square root of 5 is irrational. To solve this question, we will use the contradiction method. First, let us assume that square root of 5 is a rational number. So, we can write root 5 is equal to upon b, where a and b are coprime integers and b is not equal to 0. Now, squaring both sides, we get 5b square is equal to a square. Since a square is divisible by 5, we can say that a is also divisible by 5. Now, let's continue this proof in the next slide. Let a is equal to 5k, where k is an integer. Substituting this value into the equation, we get that b square is also divisible by 5. Therefore, b is also divisible by 5. But this is not possible because we assume that a and b are coprime numbers. Now, both numbers are divisible by 5, which contradicts our assumption. Therefore, our assumption is wrong. Hence, square root of 5 cannot be expressed in the form of p upon q. Therefore, square root of 5 is an irrational number. Now, let's move to question number 2. The question says, prove that 3 plus 2 root 5 is irrational. Again, let us assume that 3 plus 2 root 5 is a rational number. So, it can be written in the form of p upon q. Now, shifting 3 to the right-hand side and dividing by 2, we get root 5 is equal to p minus 3q upon 2q. Let's see what conclusion we get in the next slide. Since p minus 3q upon 2q is a rational number, it means root 5 should also be rational. But we already know that root 5 is an irrational number. This contradicts our assumption. Therefore, our assumption is false. Hence, 3 plus 2 root 5 is an irrational number. Now, let's move to question number 3. In this question, we have to prove that the following numbers are irrational. The first is 1 upon root 2. The second is 7 root 5. And the third is 6 plus root 2. We will solve all three parts one by one using the same logical approach. So, let's begin with the first part in the next slide. Now, let's solve the first part of question number 3. We have to prove that 1 upon root 2 is irrational. First, let us assume that 1 upon root 2 is a rational number. So, we can write it in the form of a upon b, where a and b are coprime integers. Now, squaring both sides, we get 1 upon 2 is equal to a square upon b square. After cross multiplication, we obtain 2a square is equal to b square. Since b square is divisible by 2, we can say that b is also divisible by 2. Now, let b is equal to 2c, where c is an integer. Substituting this value into the equation, we find that a is also divisible by 2. But this is not possible because a and b were assumed to be coprime numbers. Now, both numbers are divisible by 2, which contradicts our assumption. Therefore, our assumption is wrong. Hence, 1 upon root 2 is an irrational number. Now, let's move to the second part. We have to prove that 7 root 5 is irrational. Again, let us assume that 7 root 5 is a rational number. Then, it can be written in the form of a upon b, where a and b are coprime integers. Now, dividing both sides, By 7, we get root 5 is equal to upon 7b. This means root 5 also becomes a rational number. But we already know that root 5 is an irrational number. This is a contradiction. Therefore, our assumption is false. Hence, 7 root 5 is an irrational number. Now, let's solve the third part. We have to prove that 6 plus root 2 is irrational. First, let us assume that 6 plus root 2 is a rational number. So, it can be written in the form of p upon q. Now, moving 6 to the right-hand side, we get root 2 is equal to p minus 6q upon q. Let's see the conclusion in the next slide. Now, let's see the conclusion. Since p minus 6q upon q is a rational number, it means root 2 should also be rational. But we already know that root 2 is an irrational number. This contradicts our assumption. Therefore, our assumption is false. Hence, 6 plus root 2 is an irrational number. With this, all parts of question number 3 are completed successfully. In this exercise, we proved different numbers to be irrational by using the contradiction method. The most important point to remember is whenever our assumption leads to a contradiction, our assumption becomes false. This is the basic idea used in almost every proof of irrational numbers. I hope this concept is now clear to all of you. With this, we have completed exercise 1.2 successfully. I hope all the questions are clear to you now. If you found this video helpful, please like the video, share it with your friends, and subscribe to Kirti classes for more easy mathematics lectures.